Hello students, in the last class we have discussed continuity and differentiability and differentiation and the various differentiation values of some standard functions like x power n, what is the derivative of x power n, derivative of log x, derivative of a power x, and some other functions, trigonometric functions, sin x, cos x, tan x, cot x, secant x, cosecant x, and derivative of constant, derivative of log x. So derivative of e power x. So we have seen such functions and its derivatives. Now what we are going to discuss is derivative of inverse trigonometric functions. We will discuss formulas instead of going to first derivative principle again and again. We will see what is the result, what is the derivative of inverse function, and you have to remember this results also because this will be very helpful in solving problems in integrals and applications of integrals. You will directly use these formulas, so you should remember what is the derivative of inverse functions, trigonometric functions, and algebraic functions, exponential function, log function. So you have to remember all these formulas. And what is the derivative of sin inverse x? Derivative of sin inverse x is equal to 1 by square root of 1 minus x square. Derivative of cos inverse x, again it is same as sin inverse x, but there will be minus sign, minus 1 by square root of 1 minus x square. You should remember this results. And another important thing to note is here x belongs to minus 1 to 1 because only in between minus 1 to 1 sin inverse x exists, and when we have to find the derivative of a function, that function should exist and it should be differentiable in the entire interval. We have seen what is differentiability, and when a function will be differentiable in an interval, that function should be defined first. So sin inverse x, cos inverse x is defined in minus 1 to 1, and in that region this function's derivative is given by this formula, right? Next is derivative of tan inverse x. Derivative of tan inverse x is equal to 1 by 1 plus x square. This is very important, students. Derivative of sin inverse x and tan inverse x are frequently used in many problems. So you should remember these two results very good. You should answer this within 1 second just by looking at what is the derivative of tan inverse x. 1 by 1 plus x square. Derivative of sin inverse x. 1 by square root of 1 minus x square. You should answer this very fast. Here d by dx of tan inverse x is equal to 1 by 1 plus x square. And cot inverse x, it is minus 1 by, just like cos inverse x, here we will have minus 1 by 1 plus x square. Derivative of secant inverse x. Secant inverse x is defined in the interval x of minus 1 to 1. It is defined in all real number. We already know the graph of inverse functions. We have discussed this in ITF, inverse trigonometric function chapters. So here derivative of secant inverse x is given by 1 by x into square root of x square minus 1. Similarly, derivative of cosecant inverse x. Derivative of cosecant inverse x is given by minus 1 by x into square root of x square minus 1. Find the derivative of sin inverse of root x. Now by observation, what is this function? It is actually a composite function. That means we have to use chain rule for differentiation of this function. And how to apply chain rule? In the previous class we have discussed, we have to start from left hand side and see the function type and use derivative of that function and keep on multiplying the function, keep on getting the function's derivative from left to right. So here this is of the form sin inverse of some x. So what is the derivative of sin x? Sin inverse x, that will be derivative of sin inverse x is given by 1 by square root of 1 minus x square. So first we will do derivative of sin inverse and then we will do into derivative of root x. So first is 1 by square root of 1 minus, in place of x we have root x, so substitute root x square into derivative of root x. So what is the answer, students? 1 by square root of 1 minus root x square is x into 1 by 2 root x. Derivative of root x is 1 by 2 root x. So final answer is 1 by 2 into root x into root 1 minus x, that is root into root of x into 1 minus x. So 1 by 2 root x minus x square, multiply x into 1 minus x, that is this answer. This is how we should solve for inverse trigonometric functions. Next question, find the derivative of tan inverse of cos of root x. Again, this question is also similar to previous. Now what we need to do? First, apply the derivative of tan inverse. That will be derivative of tan inverse equal to 1 by 1 plus x square. Derivative of tan inverse x is 1 by 1 plus x square. So derivative of tan inverse of cos of root x equal to 1 by 1 plus cos square of root x. Remember, don't take root x square, cos root x square. That is a common mistake students commit while solving these types of questions. Now what is the derivative of tan inverse x? 1 by 1 plus x square. So in place of x, we have cos root x. That means 1 by 1 plus cos root x into cos root x is cos square root x. And derivative of cos of root x. Derivative of cos of root x. This will be derivative of cos x is minus sin x. So this will be minus sin root x into derivative of root x. So what is the answer? 1 by 1 plus cos square root x into derivative of cos is minus sin. So minus sin root x into derivative of root x. That is equal to minus sin root x divided by 1 plus cos square root x into 1 by 2 root x. This is the final answer. Next is parametric form. If x equal to, now we will come to methods of differentiation. Until now we have seen formulas for differentiation and algebra of differentiation. That is when we have sum or difference of two functions, product of functions and quotient of function, how to differentiate its value. Then we have also discussed what is chain rule of differentiation. Now what we will do is consider the methods of differentiation. If functions are of certain types, what method can be applied for finding the differentiation? Now first method is parametric form of differentiation. What is meant by parametric form? Parametric form of a variable or function is nothing but writing the function in terms of another variable. Here generally we write a function in terms of y is equal to f of x. That means there are two variables, one is y, another is x, and we plot the graph of a function by using x as well as y coordinate. So x comma y will give the points of the graph function. So here we get, instead of writing x and y, we convert x and y into some other variable, for example t. Then x is a function in terms of t and y is a function in terms of t. X and y are two differentiable functions at t. Then its derivative dy by dx is given by, for finding dy by dx, we already know what is dy by dx. I have already discussed. For finding dy by dx, what we do? We have to find dy, which is nothing but a small change in y value with respect to small change in t. And what is the change in x value with respect to change in t? So what we are actually calculating is, with respect to t, how much is the change in y and how much is the change in x variable, and we are dividing this. That means we will get what is the change in y variable with respect to x variable. That gives us dy by dx. So dy by dx is equal to dy by dt divided by dx by dt. Next question, if x is equal to sin t and y is equal to e power t plus cos t, then find dy by dx. What is the formula, students? Dy by dx is equal to dy by dt divided by dx by dt. So x is equal to sin t dx by dt will be differentiate sign, that will be cos, and y is equal to e power t plus cos t. Again differentiate that, then we will have differentiate e power t, that is e power t, cos t differentiation minus sin t. So dx by dt is d of sin t, that is cos t, and y is given by this, so dy by dt will be e power t minus sin t. Now what is dy by dx? Dy by dt by dx by dt, that is equal to dy by dt is e power t minus sin t divided by dx by dt is cos t. This is the final answer, dy by dx. And now dy by dx, in the previous questions we have obtained the result in terms of x. Dy by dx is in terms of x or constant. But here when we differentiate in parametric form, we get dy by dx in terms of variable t. That is okay. You can leave it as it is. For solving problems in parametric form, you can write the differentiation answer in another variable, parametric variable itself, that is t. That is okay, students. It is not wrong, so you can write it like this itself. Next method of differentiation is implicit differentiation. Now what is implicit differentiation? What is an implicit function first? There are two types of function. One is implicit, another one is explicit. What is an implicit function? Any function is called an implicit function if we cannot write one variable in terms of exclusively another variable. What I mean by that is, you can write y is equal to some function of x. It will always be written as a function of x and y together. You can't split x and y variable, write y variable in one side, left hand side, and write x variable in right hand side. That is not possible. Such functions are called implicit functions. The method of finding dy by dx of an implicit function is given by the relation f of x comma y equal to 0. What does that mean? F of x comma y equal to 0 means we can't split x and y variables separately. I will give one example for this. We will consider different scenarios. First function, x square plus y square equal to r square. Second function, x square plus 2xy plus y square equal to 0. Third function, x square plus xy plus y square minus 4x plus 6y minus 5 equal to 0. Now by observing these three cases, these three functions, which one is implicit and which is explicit? We will consider other examples also. For easy understanding, we will take y square equal to 4ax. Another example, y square plus x square minus 8x plus 5 equal to 0. Now by considering these examples, what are the functions which are implicit and what are the functions that are explicit function? By observation, here we can write y square equal to r square minus x square, which means this can be written as y square equal to r square minus x square, which means y is equal to plus or minus square root of r square minus x square. What does that mean? It means we can write y in terms of x as a function of x. That is, this is an explicit function. X square plus 2xy plus y square equal to 0. Can we split this? This is nothing but x plus y whole square equal to 0. This means x plus y whole square equal to 0, which means x plus y will be 0, which means y is equal to minus x or x equal to minus y, which means this is again an explicit function, a function which can be written in terms of x and y variables separately by some easy ways, easy simplification procedures. Those functions are called explicit function. So when we write it like this, this is an explicit function. Now the third condition, can we split x and y variable easily? It doesn't appear like that. Or we will take another example. Sin of xy equal to constant. We will consider these cases. Can we split this function in terms of x and y variables separately and write it separately? It is not easy to split this, so that means this will be a implicit function. Say fourth case, it is already in y variable is separate, x variable is separate, so this is an explicit function. Fifth case, again y square is equal to remaining terms are all x and constant, so we can write y in terms of x, that means this is an explicit function. Sixth one, sin of xy, can we write xy separately? It is not easy to split directly, so what we will have is xy cannot be split directly, means this will be an implicit function, or we can write xy equal to sin inverse a, y is equal to sin inverse a divided by x, then that will become explicit function. So we can make an implicit function into explicit function if it is easy to write x in terms of y or y in terms of x, otherwise it is an implicit function. That is what is given. Implicit functions, implicit differentiation is a relation given by f of x comma y. That means you can't split x and y terms separately easily. It is known as implicit differentiation. For example, x square plus y square equal to a square. Then find dy by dx. Now what is it? How to differentiate this? We already know how to differentiate basic functions. We will use the same procedure, dy by dx. That means this entire value is considered as x, so we have to differentiate, directly differentiate entire both sides, left hand and right hand side. That is the common procedure or step for finding differentiation of implicit functions. What we will do is differentiate the entire value without considering or writing y in terms of x. If you want to write y in terms of x, then y square equal to a square minus x square, and then we have to differentiate. Instead of that, we can directly differentiate and write. That will be dy by dx of x square plus d by dx of y square equal to d by dx of a square. What is d by dx of x square? Differentiation of x square is 2x. Differentiation of y square, again it is of the form x power n, so we need to apply the same formula, derivative of x power n, that will be nx power n minus 1. So here also we will get 2y into differentiation of y. Variable is not x, so we have to differentiate y with respect to x, that will be dy by dx equal to a square is a constant term, differentiation of constant is 0. Now from this we need to rewrite what is dy by dx. dy by dx is equal to minus of 2x by 2y, that is minus x by y. dy by dx equal to minus of x by y. Next type of differentiation is logarithmic differentiation. Okay, this is again very important type of differentiation, and we will use logarithmic differentiation whenever we have higher powers of x or rational powers in x and there are multiple terms. Then we can use logarithmic differentiation. Or in another case, when we use log differentiation is when there is a function raised to power some other function. That means f of x power g of x. When terms are like that. For example, x raised to power sin x, x power sin x. log x power x, sin x power sin x. When terms are x power x, when terms are like that, it is preferable to use logarithmic differentiation because we don't know any formula for directly finding differentiation of such functions which have powers with another function. So what we need to do is take log on both sides and then differentiate. That is the method for finding log differentiation. So here, if a function is of the form f of x power g of x, where f of x and g of x are functions in x, then we use logarithm to find dy by dx. With question you will understand this better, very easy. The methods of finding dy by dx is known as logarithmic differentiation. We will consider an example. Find the differentiation of log x power tan x with respect to x. So this is very important. With respect to x, we have to differentiate. What is the function? Log x power tan x. Now this cannot be assumed as x power n formula or a power x formula because x is both in base as well as in power. So we don't know which formula to use for that. So then what we will do is take log on both sides. Y is equal to log x raised to the power tan x. Apply log base e on both sides. Then we will get log of y is equal to, this will be log x power tan x. And what is log x power m? That is equal to m into log x. This power will go to numerator. We already know properties of logarithm. So this power will go to numerator. That means log y is equal to power is tan x into log x. Now differentiate this. What is differentiation of log y? That is differentiation of log x is 1 by x. With respect to x we are differentiating. So that means differentiation of log y is 1 by y into dy by dx. Okay. Differentiation of log y is 1 by y into dy by dx equal to differentiation of tan x into log x. Again, this is a product of two functions. Then we need to use product rule, u v dash plus v u dash. That means dy by dx of log x into, keep tan x as it is, plus log x is kept as it is into differentiation of tan x. Now 1 by y into y dash equal to tan x into, what is the differentiation of this? Log x. That will be log x differentiation is 1 by x. So log x will be 1 by log x into log x differentiation. That will be 1 by x. So 1 by log x into 1 by x plus log x into differentiation of tan x, that is secant square x. So dy by dx equal to y into, finally multiply 1 by y dash equal to this value. So y dash equal to y into this value. And what is y? That is log x power tan x. What is the function that is given? So final answer comes out to be dy by dx equal to log x power tan x into, write this remaining expression. This is the final answer. So this is how we will do logarithmic differentiation. Whenever we have power function raised to the power another function, then we will use log differentiation. Next is transformations. The derivative of some functions can be found simply by using trigonometric substitutions. Now this transformation can be used. This is mainly for simplifying a differentiable function into simpler functions which will be converted into standard form if preferable, if possible. Then we will use that method. First by substitution we will try to convert this into standard form and then differentiate. For example, we will discuss with some questions. Find the derivative of tan inverse of a minus x by 1 plus ax with respect to x. We can also differentiate this directly by using chain rule. Then we will get differentiation of tan x 1 by 1 plus x, a minus x by 1 plus ax squared into differentiation of this. That will be again quotient rule, u by v form. Again we have to apply the formula for that. So it will be very lengthy question. Instead what we will do is try to simplify this term. We already have tan x here. So what is our purpose of using this substitution transformation? We have to reduce this function into simpler terms. Try to simplify this. Now what can be substituted for this? Solution. Let a equal to a equal to tan alpha. Okay, can we make this substitution? Remember, whenever we are making a substitution, we have to be careful about the domain should match between both the function and the range should also match. Otherwise, we can't make the substitution. So here, a equal to tan alpha and x is equal to tan theta. Why can we make this substitution? Because a can be any real number and tan value can also be any real number. When we make a equal to sin theta, for example, that means this value a should always lie between -1 to 1. Only if that condition is satisfied, you can make that substitution. Otherwise, you should not make. For example, I am telling how to make substitutions. Now here, a equal to tan alpha and x is equal to tan theta. So tan inverse of this inside expression will become, we will see the solution. This will become tan inverse of tan alpha minus tan theta divided by 1 plus tan alpha into tan theta. And what is the formula for this? This is tan a minus tan b by 1 plus tan a tan b. What is the formula, students? Tan of a minus b. So this formula becomes tan inverse of tan of alpha minus theta. So this is nothing but tan inverse of tan of alpha minus theta. And what is tan inverse tan theta? That is nothing but theta. So here we will get is equal to dy dx of alpha minus theta. And what is the differentiation of alpha minus theta? Again replace alpha and theta in terms of x. So this is nothing but alpha is nothing but tan inverse of a, not tan inverse alpha. A equal to tan alpha. So alpha equal to tan inverse of a. This is tan inverse a. Minus theta is nothing but tan inverse of x, because x is equal to tan theta is the substitution. That means theta is equal to tan inverse of x. Now what we got, students? This entire differentiation is nothing but differentiation of tan inverse of x minus tan inverse of x. That is equal to minus of tan inverse x differentiation is 1 by 1 plus x square. So the entire differentiation process becomes very simple. It is actually a standard definition of derivative, standard derivative of inverse function. We already know how to formula for inverse trigonometric functions. Tan inverse x derivative is 1 by 1 plus x square minus of tan inverse x, that is minus 1 by 1 plus x square. Next question. Find the derivative of sin x power log x plus x power sin x with respect to x. Now by observation, can we differentiate this directly? No, we don't have any formula for finding differentiation of this directly. So what we will do is try to take these two terms separately and differentiate it first separately and then add both, because we can't differentiate it directly by taking log on both sides, because we already know when there is function in the base, rise to power is also function, then we will use log for differentiation. Here we can't directly use log of this entire expression because we don't have formula for log of a plus b. So what we need to do is take this function first term separately and second term separately and differentiate both and finally add the derivatives. So this is nothing but dy by dx is nothing but dy by dx of first term plus dy by dx of second term. Now what we will do is let u is equal to first term sin x power log x. Then we will find du by dx, that is this first term, and second term will be, say this is v, so dv by dx will be second term. Final answer du by dx equal to du by dx plus dv by dx. Apply log on both sides. Then log u is equal to log of sin x power log x and we have to, that's what I discussed here, log of a plus b is not equal to log a plus log b. That's why we have to take these two values, two terms separately and differentiate first. Now this will be log u is equal to log x into log of sin x. Log u is equal to log x into log of sin x. And what is this value? dy dx of log u is equal to dy dx of log x into log of sin x. Differentiation of log u, that is 1 by u with respect to x. So we have to differentiate u with respect to x. So this value is 1 by u into du by dx, that is equal to differentiation of, this is a product of two functions, so we have to apply UV rule. That is, first differentiate log x, that is 1 by x, into write the other value as it is, log of sin x, plus differentiate, keep log x as it is and differentiate log of sin x. That will be log x differentiation is 1 by, so it is 1 by sin x into differentiation of sin x is cos x. Now simplify this. Du by dx equal to u into this value. What is u? Sin x power log x into write the other term as it is. So this will be cos x by sin x is cot x. So it will be cot x into log x. Next, p is equal to x power sin x. This is the second term. Again we will use the same procedure for finding the value. V equal to x power sin x. Apply log on both sides. Log v is equal to sin x into log of log x. Sorry, sin x into log x. X power sin x, no, sin x into log x. Again, this will be when differentiating 1 by v into v dash dv by dx equal to differentiation of sin x is cos x into keep log x as it is plus differentiate log x, that is 1 by x into keep sin x as it is. So final answer is dv by dx equal to v into this value. What is v? X power sin x. Substitute in there. So v equal to x power sin x, dv by dx equal to x power sin x into cos x log x plus sin x by x. And now what is dy by dx? That is nothing but du by dx plus dv by dx. So final answer becomes, substitute the entire value. First term differentiation plus second differentiation. So this is how we will use logarithm for finding differentiation of different functions, especially of the type function f of x raised to power z of x. Next question is, find the derivative of secant inverse of 1 by 2x square plus 1. Again by observation, if you can differentiate this directly, that is well and good, but it is a very big function. Inside we have 1 by 2x square minus 1. Now if we have to differentiate this directly, then what is the formula for differentiation of secant inverse? 1 by mod x into root of x square minus 1. In place of x, we have quotient 1 by 2x square minus 1. So it will be very big process for finding differentiation. Again we have to differentiate this. So instead what we will do is try to use substitutions for making the function simpler. Now what is the substitution can we make? Can you think of and tell students? What does this term resemble? 2x square minus 1. Have you seen this formula anywhere? Think about trigonometry. What are the different formulas? Sin 2 theta, cos 2 theta, tan 2 theta. Does any formula resemble this term? Yes. What is cos 2 theta? Cos 2 theta is equal to 2 cos square theta minus 1. So here when you substitute x is equal to cos theta, this term becomes 2 cos square theta minus 1, which is cos 2 theta. So this will be 1 by cos 2 theta. We will see the solution. We will substitute x is equal to cos theta. When you substitute x is equal to cos theta, that means theta will be cos inverse of x. Yes. Then y is equal to secant inverse of 1 by 2 cos square theta minus 1. And what is this? Cos 2 theta. And what is 1 by cos 2 theta? 1 by cos is secant. So this will be secant inverse of secant 2 theta. which is nothing but secant inverse secant theta is theta itself. So secant inverse secant 2 theta becomes 2 theta. And what is theta? Cos inverse of x. So this entire function becomes simplified into 2 cos inverse x, which is again direct formula. What is the differentiation of cos inverse? Minus 1 by root of 1 minus x square. So our final answer is minus 2 by root over 1 minus x square. Next question. X is equal to a into cos t plus t sin t and y is equal to a into sin t minus t cos t. Okay, we should find dy by dx. Find dy by dx. Find dy by dx. Now, what is this? It is actually in parametric terms. X is equal to in terms of function of t and y is again a function of t. So, when we have x and y in terms of t, then what is dy by dx, students? Remember the formula. What is dy by dx? Dy by dx is equal to dy by dt divided by dx by dt. Or you can also write dy by dx equal to dy by dt into dt by dx. Both are same. So here y is equal to a into this value. So dy by dt will be equal to a into differentiation of this term dy with respect to t. What is the differentiation with respect to t? Sin t differentiation is cos t. A is constant and it is outside. So differentiation is a into differentiation of sin t minus of a into differentiation of t cos t. Now what is this? Differentiation a into cos t. First term differentiation of sin t is cos t minus a into differentiation of t cos t. Again we have to apply product rule. T into minus sin t differentiation of this. Then cos t into differentiation of t is 1. So what is the final answer, students? Dy by dt is equal to a cos t minus of a into t into minus sin t plus cos t. So final answer is a cos t plus a t sin t minus a cos t. A cos t will get cancelled, so it is a t sin t. Dy by dt is equal to a t sin t. Now we have to see what is dx by dt. Again x is given by a into cos t plus t sin t. What is dx by dt? That is equal to a is constant. Again we will keep it outside and differentiate cos t plus differentiate t sin t. That is equal to a is constant, it is outside, differentiation of cos t is minus sin t, differentiation of t into sin t, t into differentiation of sin t plus sin t into differentiation of t, a into minus sin t plus t into differentiation of sin t is cos t plus sin t into differentiation of t, that is 1. Which is equal to minus a sin t plus this plus sin t minus sin t will get cancelled anyways. So final answer is a t cos t. This is equal to a t cos t. Now what is dy by dx? Dy by dx is equal to dy by dt divided by dx by dt. And what is dy by dt? A into t into sin t. Dx by dt is a t cos t. Now a t both are same, so it will get cancelled out. Remaining sin t by cos t. What is sin by cos? Tan. So a t, this will be sin by cos is tan. Tan t. Next question. Find the differentiation of derivative of x power x with respect to x. Find the differentiation of x power x with respect to x. Again it is very simple. By the observation from the question itself, you should understand what concept or what method of differentiation is to be applied for this question. So this is of the form f of x power g of x. That means you have to use logarithm. When you have parameter, you should think, okay, x and y are in different variables, that means we have to use dy by dx equal to dy by dt by dx by dt. Here it is in the form f of x power g of x, that means first we have to apply log. This is a standard step. So whenever there is a method of differentiation is given, so that entire process of finding differentiation gets simplified. You just have to remember, okay, question is applying like this, question is coming in this form means you have to apply, you have to proceed in certain way. You have to take logarithm, or you have to use parametric form, or you have to use product rule, quotient rule, chain rule, whichever is possible. So whatever you have learned until now, we are only going to see questions from that. There won't be any question outside of this. So you just need to know which formula or which concept or which method of differentiation is to be applied for certain questions. So here it is x power x. So how to find x power x? Apply log on both sides. It is a from logarithmic differentiation method. So this will be log on both sides. When you take log y is equal to log of x power x. This power x will go to numerator, that will be x into log x. So we will get log y is equal to x log x. And now differentiate this. Differentiation of log y is 1 by y into y dash, 1 by y into dy by dx equal to differentiation of x log x. That will be x into differentiation of log x plus log x into differentiation of x. So what is the final answer we get? 1 by y into dy by dx into x into differentiation of log x, that will be 1 by x. These two will get cancelled, it will be 1 plus log x into differentiation of x is 1. So final answer becomes 1 plus log x. So dy by dx equal to y into 1 plus log x. What is y? X power x. So final answer is dy by dx equal to x power x into 1 plus log x. Next question, find dy by dx if y is equal to sine inverse of 2x by 1 plus x square. Y is equal to sine inverse of 2x by 1 plus x square. Again an interesting question. What we need to do is substitute x equal to some value, so this entire function becomes simplified. Because if you are to differentiate this directly, again it will be very big, formula for differentiation, derivative of sine inverse x. So instead of directly using differentiation method, we will try to simplify the function y, then we can differentiate that. How to simplify? Substitute x equal to, what does this formula term resemble? It is of the form, when you substitute x equal to tan theta, we have 2 tan theta by 1 plus tan square theta. What is the formula, students? 2 tan theta by 1 plus tan square theta is sin 2 theta. So here we will get sin inverse of sin 2 theta. Substitute x equal to tan theta, then y is equal to sin inverse of 2 tan theta by 1 plus tan square theta, which is nothing but sin 2 theta. So this entire value becomes sin inverse of sin 2 theta, which is nothing but 2 theta, where theta is tan inverse x. That means y becomes 2 into tan inverse x. Now what is the differentiation of 2 tan inverse x? 2 by 1 plus x square, simple. So differentiation of this is 2 by 1 plus x square. Next question, find the derivative of tan inverse of root of 1 plus x square minus 1 divided by x. Again, how to do differentiation? Differentiation of derivative of tan inverse of square root of 1 plus x square minus 1 divided by x. Now again when we apply the formula, it is very big. So these types of questions are given. I have chosen this question mainly to understand what type of substitution we have to make for different kinds of functions. So in the previous examples, how the functions are, if there is 1 minus x or 2x by 1 plus x square, if terms are like that, then based on the formula and based on the inverse value here, you have to choose a formula so that the entire function will become simplified. For this question, what is the substitution we can make? Can you think and tell? Square root of 1 plus x square. So when you have to make this term simplified, when you have to simplify this expression here, Then substitute some value of x, so that first we will reduce the root into simpler terms. Now what is the substitution we can make? We already know what is 1 plus tan square theta, that is secant square theta. So if you substitute x is equal to tan theta here, then we will get 1 plus tan square theta is secant square theta, square root of secant square theta is secant theta. So this term will get simplified. So substitute x equal to tan theta, which means theta equal to tan inverse of x. Now y is equal to square root of 1 plus tan square theta minus 1 divided by tan theta. 1 plus tan square theta minus 1 divided by tan theta. This is secant square theta. Square root of secant square theta is secant theta. So this is secant theta minus 1 by tan theta. What is secant theta, students? 1 by cos theta. So this is 1 by cos theta minus 1 divided by tan theta is sin theta by cos theta. Now take LCM in numerator, that will be 1 minus cos theta by cos theta. For denominator we have sin theta by cos theta. Here cos theta will get cancelled, remaining will be 1 minus cos theta by sin theta. So y is equal to tan inverse of 1 minus cos theta by sin theta. Again we have to simplify this. Now first from a bigger expression we have simplified it into some standard smaller trigonometric function. Now again we have to simplify this expression into further smaller term. Now we have to use the formula 1 minus cos 2 theta. What is 1 minus cos 2 theta? 2 cos square theta, and this is of the form sin 2 theta, which will be 2 sin theta cos theta. We will apply those formulas here and see what will happen. 1 minus cos 2 theta will be, that is 1 minus cos theta will be 2 cos square half the angle, 2 sin square half the angle. 1 plus cos theta is 1 plus cos 2 theta is 2 cos square theta. 1 minus cos 2 theta is 2 sin square theta. So it is 1 minus cos theta is 2 sin square half the angle here, that is theta by 2. Now sin theta, this is of the form sin 2 theta. Sin 2 theta is equal to 2 into sin theta into cos theta. So sin theta will become 2 into sin of half the angle theta by 2 into cos theta by 2. Now substitute these values here. That means in numerator we have 2 sin square theta by 2. In denominator we have 2 sin theta by 2 cos theta by 2. 2 will get cancelled. 1 sin theta by 2 will get cancelled. So we will be left with sin theta by 2 by cos theta by 2. And what is the sin by cos? Tan. So these two will get cancelled. We will have sin theta by 2 by cos theta by 2, which is tan inverse of tan theta by 2. Again tan inverse tan theta is theta. So final answer is theta by 2. And what is theta? We have substituted x is equal to tan theta. Remember what we substituted for x, and again write this in terms of x, because we have to differentiate y with respect to x, not theta. So in final answer always remember to redo the substitution. Again replace theta with x. So half theta is half of tan inverse x. Now what is the derivative of this? 1 by 2 of 1 by 1 plus x square. So this is the final answer. Next question. Find dy by dx if y is equal to tan inverse of, find dy by dx if y is equal to tan inverse of square root of 1 minus x by 1 plus x. Okay. Now again we will use the trigonometric substitution. Try to simplify this term. If you substitute x is equal to cos theta or cos 2 theta, we can substitute both. Either you can choose cos theta or cos 2 theta. Then we have seen in the previous question what is the formula for 1 minus cos 2 theta? 2 sin square theta. 1 minus cos 2 theta is equal to 2 sin square theta, and 1 plus cos 2 theta will be 2 cos square theta. So final this expression will simplify into substitute x equal to, okay, here we will substitute cos theta. You can substitute either cos 2 theta or cos theta. Theta will be cos inverse of x. y is equal to tan inverse of square root of 1 minus cos theta by 1 plus cos theta. So tan inverse of square root of 1 minus cos theta is 2 sin square theta by 2. 1 plus cos theta is 2 cos square theta by 2. 2 will get cancelled. Sin by cos becomes tan. So it will be root of tan square theta by 2, that is tan theta by 2. So y is equal to tan inverse of tan of theta by 2. And what is tan inverse tan theta by 2? That is theta by 2. So value will be y is equal to theta half of theta, that is theta by 2. Now this is half of what is theta? We have substituted x is equal to cos theta. So theta is cos inverse x. Substitute theta as cos inverse x. And now differentiate with respect to x. So dy by dx will be equal to half of dy by dx of cos inverse x is minus 1 by square root of 1 minus x square. So final answer is minus 1 by 2 into square root of 1 minus x square. Next question, find dy by dx if y is equal to tan inverse of this term. Again, by looking at the question, we have to identify what kind of substitution we have to make so that this entire expression will be simplified. By the first term, when you look at it, we can substitute x equal to tan theta, then 1 plus tan square theta will be secant square theta. We can simplify this. Now what about this term 1 minus tan square theta? We don't have any formula for that. That means you should not substitute tan theta. Then what other substitution can we make? Sin theta, we don't have formula for 1 plus sin square theta. Cos theta, 1 plus cos square theta, 1 minus cos square theta. Instead we can substitute x square is equal to cos theta or cos square theta, cos 2 theta. Then we will have 1 plus cos 2 theta, 1 minus cos 2 theta. That has some formula. So this means we don't need to substitute only for x. We can also consider x square is equal to some value. And why can we substitute x equal to sin theta or cos theta in this question? Because it is inside square root and we have 1 minus of x square. That means this term should always be positive for square root to exist. Yes or no? 1 minus x square should always be greater than 0. Only then we will have this function. That means x will always be less than 1 and it should be x square is always greater than 0. That is obvious. So that means x will lie between minus 1 to 1. True or false? Only then this second term will exist. Square root of 1 minus x square. And we have to take a substitution. Substitute some value which will satisfy that. So which trigonometric value will have its range between minus 1 to 1? Only those values could be substituted for this question. That means we can substitute sin theta or cos theta. You can't substitute tan theta in the question. Do you understand how to choose substitution? So here y is equal to tan inverse of square root of 1 plus x square plus 1 minus x square square root divided by minus of this. Again we will substitute now x square is equal to cos theta, which means theta is equal to cos inverse of x square. Remember, this is not 2 cos inverse x or something else, right? Whichever is here in the term x square, that is like y. So y is equal to cos theta means theta will be cos inverse of y. So theta is cos inverse of x square. So again y becomes tan inverse of root of 1 plus cos theta plus root 1 minus cos theta. Again root 1 plus cos theta minus root 1 minus cos theta. What is 1 plus cos theta? 2 cos square theta by 2. 1 minus cos theta is 2 sin square theta by 2. Substitute those values. 1 plus cos theta is 2 cos square theta by 2. 1 minus cos theta is 2 sin square theta by 2. So y is equal to tan inverse of this term. After substitution, root 2 is common in this numerator as well as denominator. So we can take root 2 outside. square root of cos square theta by 2, square root of x square, that will be x. So we will have cos theta by 2 plus sin theta by 2 divided by cos theta by 2 minus of sin theta by 2. So root 2 will get cancelled. We will have cos plus sin by cos minus sin. Cos plus sin by cos minus sin. And this is equal to tan of pi by 4 plus theta. Why is that? We will try to solve this, how this formula is applied here. Root 2 will get cancelled. This is equal to tan inverse of. We will take cos theta by 2 outside from the numerator and denominator. In numerator, if you take cos theta by 2 outside, it will be 1 plus sin theta by 2 divided by cos theta by 2, that will be sin by cos is tan. Do you understand why we do this? When we take cos theta by 2 outside, cos theta by 2 into 1 plus sin by cos becomes tan. In denominator, again this will be 1 minus of tan theta by 2. Cos theta by 2 will get cancelled out. So this is equal to tan inverse of. We can write this one as tan 45 degree. Tan 45 degree plus tan theta by 2 divided by 1 minus 1 is tan 45, so we can write tan theta by 2 as 1 into tan theta by 2, that will be tan pi by 4 into tan theta by 2. Now what is the value? Tan A plus tan B by 1 minus tan A tan B is tan of A plus B. So this is equal to tan inverse of tan of A plus B pi by 4 plus theta. Now this will be equal to pi by 4 plus theta. Pi by 4 plus theta. So this final expression y becomes pi by 4 plus theta. Tan inverse tan pi by 4 plus theta by 2. So this will be pi by 4 plus half of theta, and what is theta? Cos inverse of x square. Now we will differentiate this. Differentiation of pi by 4 plus cos inverse x square, half cos inverse x square. Differentiation of constant is 0. Pi by 4 is nothing but a constant, so it is 0. And then 1 by 2 of dy dx of cos inverse differentiation is 1 by square root 1 minus x square. So it will be x square squared into dy dx of x square. That is equal to half of minus dy dx of x square is 2x divided by 1 minus x power 4. So final answer is this 2 and 2 will get cancelled out, remaining minus x by square root 1 minus x power 4. Next topic is differentiation of a function with respect to another function. Suppose f of x and g of x are two differentiable functions with respect to x, then the derivative of f of x with respect to g of x is given by f dash of x divided by g dash of x. You should remember this. Differentiation of a function with respect to another function. For example, they may ask differentiate log x with respect to sin x. Then how to do those questions? First we have to differentiate log x with respect to x and sin x with respect to x and divide those. F dash of x divided by g dash of x. That is the formula for this. dy by dx is equal to f dash of x by g dash of x. For example, differentiate f of x with respect to g of x for f of x equal to log x base a and g of x equal to a power x. Now what is the solution? f of x is log x base a, which can be written as log x by log a to the base e, because whenever we differentiate, remember always base should be in e. Whichever value we are differentiating, the function should always have base e. Otherwise, we have to convert it into base e and then apply differentiation or integration. Then you won't make any mistakes in this. So, f of x equal to log x will be log x by log a, and now differentiation of this is 1 by log a is constant. Keep it as it is. Differentiation of log x is 1 by x. So, final answer is 1 by x log a. Now, g of x is equal to a power x. Then g dash of x will be a power x into log a. Now, what is the final answer, students? F dash of x by g dash of x. dy by dx equal to f dash of x by g dash of x. That is equal to 1 by x log a divided by a power x into log a. So, final answer is 1 by x into a power x into log a is coming 2 times squared. That is easy. So, if you know the formula and how to apply, how to solve questions without any mistake, you can learn mathematics very easy. Next question, find the derivative of e power x with respect to root x. Again, derivative of this is f of x and this will be g of x. What is the formula? F dash of x divided by g dash of x. So, f of x equal to e power x, g of x equal to root x. Then f dash of x is derivative of e power x is e power x, derivative of root x is 1 by 2 root x. So, final answer is e power x divided by 1 by 2 root x. That will be 2 root x into e power x. Easy. Another question, find the derivative of e power sin x with respect to sin x. There are two ways to solve this question. Take this sin x as some t. Then we have to differentiate e power t with respect to t. That will be e power t itself. So, final answer will be e power sin x itself. We can do it in that way. Another way is use the formula we have known. So, that means differentiate e power sin x with respect to x and differentiate sin x with respect to x and solve. Differentiation of e power sin x will be e power sin x into cos x. You already know how to do composite function differentiations. Next one is differentiation of sin x. That will be cos x. So, what is the final answer? F dash of x by g dash of x. That is e power sin x into cos x divided by cos x. That is e power sin x. Easy. Next topic is higher order derivatives. Higher order derivatives. Last topic. 2 minutes. 2 minutes. Second order derivatives. What is the second order derivative? If f is a differentiable function on closed interval a to b, then its derivative is differentiable at x. If it is twice differentiable at x, then the derivative f dash of x is denoted by, second derivative is given by f double dash of x or f to the superscript right 2 of x, or sometimes they will give y double dash, which means second derivative of f of x. F double dash of x is denoted by d square y by dx square, or d capital D square y or y double dash, or y in subscript 2. All these notations denote second order derivative. And remember, when we write dy by dx, that represents change in y with respect to x. When we write d square y by dx square, this is not x square, change in x square and change in y squared. This is not the correct way to write. This is just a notation which represents we have differentiated the function again. That is the meaning of it. It does not have any physical meaning. When we write d square y by dx square, this does not represent change in x square, dx square. That is wrong representation or understanding of this. Right? So you cannot write d square y by du square into du square by dx square. You can't write d square y by dx square like that. Just like how we use chain rule, you can't apply that here. So whenever we have to find higher order derivative, you can't use that. Questions will be mostly in general. Either they may ask show that give second order derivative, they will give a relation and ask you to prove, or they will ask you to find the second order derivative, find d square y by dx square given a function. We will see one example. Y is equal to x power 4 plus tan x, find d square y by dx square. The procedure is very simple. First we have to find dy by dx and differentiate dy by dx again with respect to x, that is d square y by dx square. So dy by dx is equal to differentiation of x power 4 plus differentiation of tan x. What is the answer? X power n differentiation is n x power n minus 1. So this 4x cube plus differentiation of tan x is secant square x. Now second order derivative will be, again we have to differentiate 4x cube, that will be differentiation of 4x cube plus differentiation of secant square x. So that will be 4 into differentiation of x cube is 3x square plus differentiation of secant square x. This is of the form x power 2. So we have to write 2 into secant x into differentiation of secant x. That will be secant x tan x. So final answer is 12x square plus 2 secant square x tan x. This is how we should find second order derivative. Next we will solve one more question. If y is equal to a into e power nx plus b into e power minus nx, then show that d square y by dx square is equal to n square into y. Y is equal to a into e power nx plus b into e power minus nx. dy by dx equal to a into d by dx of e power nx plus b into d by dx of this. We already know how to differentiate e power x. So e power x differentiation is e power x itself and differentiate nx, that will be n. So final answer is a into n into e power nx minus of this minus n will write before, so minus n into b into e power minus nx. We already know how to differentiate e power x. Same. Now again we have to differentiate this dy by dx of dy by dx, that is d square y by dx square. So which will be equal to an into differentiate e power nx. N are constant, so we will keep it as it is. Differentiation of e power nx is e power nx into n minus of bn is constant into e power minus nx into minus n. Again simplify this. Minus bn into minus n will be plus bn square, here plus an square. So an square into e power nx plus bn square into e power minus nx. And what is this value, students? N square into a into e power nx plus b into e power minus nx, which is nothing but y. So final answer is d square y by dx square is equal to n square y. We have proved this. That is how we should solve these types of questions. With this we have completed differentiation. So we have seen continuity, differentiability and differentiation in this topic. With this we have completed this unit. So always keep learning and keep growing, students. Success is yours line by line and endigu endendigu nama tapasya.